We want to evaluate the real part of the sum from n equals 1 to 2025, given away when I'm recording this, cis pi by 6 to the power n. Let's look at what this looks like. So, the sum from n equals 1 to 2025, let's not worry about the real part just yet, of cis pi by 6 to the power n. So when n is 1, we're just going to get cis pi by 6. And when n is 2, we'll get cis 2 pi by 6. Think about how de Moivre's theorem works, which is pi by 3. And then n equals 3 would give me cis 3 pi by 6, which is pi by 2. And then when n equals 4, I'll get cis 4 pi by 6, which is 2 pi by 3. And so on. Let's go up at this point to where we get 12 pi by 6. So n is 12. So 12 pi by 6 is 2 pi. And then it would continue on from there. But let's just look at what happens with the first 12. So we're looking here at n equals 1 to 12. Okay. So let's have our argon diagram here. Now, we know all of these, because it's just cis with nothing in front, would lie on a unit circle, a circle of radius 1 centered at the origin. So cis pi by 6 would be here, pi by 3, then we've got pi by 2, 2 pi by 3, 5 pi by 6, and that's 6 pi by 6, or pi, and then we would go down. I think I probably got that a bit in the wrong place. I think they're all a little bit in the wrong place, but you get the idea of what we're doing here. There's the 9 pi by 6, which is 3 pi by 2. And we've got that one, and that one. Now, just by the symmetry, thinking about all of these as being vectors, we can see that the sum of that lot is going to be 0. So all of the stuff that I've underlined here is 0. And then the same thing is going to happen from 13 through to 24. And then from 25 through to 36. Those are all going to be 0. So we just need to get what we get left with at the end. So let's do 2025 and divide it by 12. So 2025, 12s don't go into 2, they go into 20 once with 8 over. 6 12s are 72, leaving a remainder of 10. And 8 times 12 is equal to 96. So this goes in 8 times with a remainder of 9. So we're going to have loads of these in batches of 12 that sum to 0. And then we're going to have 9 of them left at the end. Well, let's think about those 9. So I'm going to draw another argon diagram. So I've got Re and Im. And we have a unit circle like that. Let's just redraw those axes so it's more at the center. Like so. And then the ones we're going to have are here, 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 this one, this one, this one, and then we've got this one, and this one. That's 9 of them. So we're after the real part of those. So immediately we can ignore this one and this one because they're completely imaginary, so they don't have a real part. This one and this one here and this one here, let's just redraw that. I think it thought I was trying to delete. So they're going to cancel out the real parts. In other words, that distance there and that distance there are the same, but one's positive and one's negative. And we can see the same sort of thing is going to happen for that one. So we only actually get left with these 3 to sum up. So this one here is -1. Then let's think about this one here. So we know this angle here is π/6 and the length is 1. So it's going to be 1 cos π/6 because that's the adjacent. And so that is √3 on 2. And then let's think about the real part of that one. So the angle here is π/3. This is 1. This is going to be 1 cos π/3. And the cosine of π/3 is 1/2. And I've put plus -3, but it would be negative, wouldn't it? Because it's over here. And then we've got -1/2. And so we get -3 on 2, take away √3 on 2.